The Frank-Starling mechanism explains the effect of exercise and other activity on the power of the heart, including cardiac output and venous return. Typically, the heart beats at a rate of 60 to 100 beats per minute, with a stroke volume of 50 to 100 milliliters. Stroke volume is the amount of blood pumped out of the heart to the body with each contraction. Cardiac output, or total volume of blood pumped per minute, is calculated by multiplying stroke volume and heart rate and often falls around 4 to 5 liters per minute. However, in 1899, German physiologist Otto Frank and anatomist Ernest Starling developed the Frank-Starling law, stating that the heart will pump more blood when there is a greater amount of blood moving into the heart. So how can we get higher cardiac output in the body? According to Frank-Starling, activities such as exercise will cause 3 main changes: muscle contraction, increased respiration, and vasoconstriction. Muscle contractions assist in blood pumping due to tightening around veins and pushing blood towards the heart. Increased respiration, or breathing rate, causes higher pressure in the lungs and chest, creating a concentration gradient that will deliver more oxygen to the body, therefore recruiting more capillaries to carry blood. Vasoconstriction, or tightening of blood vessels, will occur to push blood to muscles and to the heart and increase overall blood flow. As more blood is fed into the heart, preload, or the amount that the heart chambers can stretch and fill with blood before contraction of these chambers, will increase drastically. The heart is pumping more blood with each contraction in order to supply muscles with oxygen. There will be an increase in heart rate, blood pressure, stroke volume, and cardiac output. As you exercise, there will also be an increase in venous return to the heart. Venous return is the amount of blood entering the heart from the veins. As more blood is let in, more blood will move out of the heart and into tissues. When the heart stretches more, myocardial fiber length will increase. Myocardial fiber length is the length of the muscle fibers specifically found in the heart. An increase in fiber length will cause the tension of this muscle fiber to increase as well. The length-tension relationship of these fibers refers to how the length of a muscle fiber compares to the force generated by that fiber. This means that the muscles of the heart will lengthen, stretch, and generate more force to be used in the contraction of the heart chambers. As a result of this increase in force, more blood will be forced out of the heart with less resistance. Afterload refers to this resistance in the heart. Afterload is greater when there is greater resistance to blood pushing out of the ventricles. However, in the case of Frank-Starling, afterload will decrease and blood will be pushed out of the heart in higher volume. This overall increase in blood inflow and outflow is evidenced by the increased contractility of the heart. Contractility is the ability of the heart to contract. Exercise causes the heart to contract more easily and more quickly in order to provide more blood to body tissues. As the heart contracts more often and with more force, end diastolic volume will increase. End diastolic volume is the volume of blood in the ventricles after the heart relaxes. The heart chambers will stretch, fill with more blood, and pump more blood out, all as a result of the increased EDV. The Frank-Starling mechanism encompasses the entire function of the heart in response to exercise and physical activity, and is the reason that we can run faster and train harder.